All right, so let's find the critical value when we have 7 paired data sets, okay? So essentially we want to do this, right? So n is equal to 7, right? Because we have 7 paired data sets. Oh, I do it here, right? Alpha is 0.05, right? It's always going to be alpha 0.05. So now we're going to look at our format sheet. So if you look at your format sheet, you bump it up. Here's your first page. You want to go to your second page. It's actually in the middle. So middle of the second page where it says critical values of the correlation coefficient. Now, if n is 7, all you're going to do is where n is 7, which is right there, and you go straight across, right here. There is your critical value. That's it. Just find n, go across, there's your critical value. So our critical value is going to be, for this example, 0.754. That's what we get. Okay. And next thing, we got to check, is it or is it not linear? And it's a simple scenario. If the absolute value of r is greater than the critical value, then there is a linear relationship. Okay. If the absolute value of r is less than the critical value, there is no linear relationship. Okay. So let me give you a quick little example. Let's suppose n is 3 and r is negative point, I don't know, let's say, actually, let's say n is 10. Let's make that easier. So let's say n is 10 and r is negative 0.771. Okay. So if we go to 10, we've got to find our critical value. So going to n is equal to 10, which is right there. So therefore, our critical value is 0.632. Now here's the thing. According to our criteria, is the absolute value of r bigger or smaller than this? Now this is the trick question, right? It's the absolute value, meaning you're always going to make this positive. So positive 0.771, is that greater than or equal to or less than 0.632, which is going to be greater than, right? Because it gets the absolute value. So since it's greater than, therefore we have a linear relationship. So for example, if this was like 0.555, then we would have no linear relationship because of that. That's it. That's all we're checking. It's just two nice little criteria if we have a linear or no when it comes to it. So a little recap before we go into a little bit more examples is the value of r tells you if it's strong, weak, positive, or negative. And now using r, we can see if we have a linear relationship or not based off that. Okay? All right. So let's try some examples out so you can see how this will work out. Okay. So the paired pizza/subway fare in cost in New York City is shown below. The linear correlation coefficient is linear. Oh, I missed that. So linear correlation coefficient is, I kind of double stated that, is that. So they give us r, right off the bat, like I said. So r is given to us in the question, 0.987. Question is, what does r tell you about the relationship between the pizza and the subway fares? Okay, well, it tells us two things, right? Since r is positive, we have a positive relationship. Right, it's a positive relationship. Okay, well, what else? Well, that's right. Is it weak or strong? So this is definitely closer to 1. So this is a strong positive relationship. So this is a strong positive relationship between the pizzas and the pizza and subway fare. And there we go. Okay. All right, and the next one, B, is there a linear relationship? So that's what we're going to talk about right now. We just talked about, right, find the critical value and all that fun stuff. So first off, we got to find n. So remember, n is a number of paired data values. So it doesn't matter what x and y is, right? Because again, r doesn't affect it. So we just count 1, 2, 3, 4, 5, 6. We have 6 pairs. So n is going to be 6. Right now, we just go to our critical value portion. N is 6, so our critical value is 0.811. All right, so our R is right here. So is this bigger or smaller than this? And you should say definitely it's a bigger, right? So we have a yes. Yes, a linear relationship. And that's it. That's pretty much the first section is all about. Just interpreting what R is, making sure you know what R is, and then just going, do we have a linear relationship or not? Okay, so let's just do one more, number 2 down here. So the data value gives the blood pressure of the right arm and then the left arm. The linear correlation coefficient for this is, again, given to us, 0.896, 0.86m. So again, same scenario, right? What does R tell us? So it's positive and also strong, right? Closer to 1. So this is a strong positive relationship between what is it? The blood pressure in the right and left arm. Okay. And next one is your linear relationship. So same thing. Gotta find n. So 1, 2, 3, 4, 5 pairing this time. So if we go to our equation sheet, and is 5, so critical value is 0.878. Oh, so smaller or bigger? So definitely R is smaller, so therefore we have no linear relationship, right? Barely slightly smaller than the critical value. Okay, so that's that portion, right? So that's pretty straightforward. The next section is what the bulk is, what you care about is that fun stuff is how do we find that line that we cross? So it's not just a random line when it comes to it, so we can actually find that line and plot it. That's what we'll talk about. And that line itself is called a linear regression line when it comes to, or another word for saying it's line of best fit, which is its slang term itself. Okay, that's the most slang term, but we'll talk about that in a little bit.